Hi, in this video, we will be taking a look at Taylor series. So what we have written here is the general form of a Taylor series centered at A. A is the center of convergence. And from n to infinity, we evaluate the nth derivative of f at A divided by n factorial. And so in this particular version of the problem that we're looking at here, we are given a table of values with derivatives of f from the zeroth derivative, which is the function itself, all the way to up to the sixth derivative evaluated at -1. And so we want to start by part A, asking us to find the third degree Taylor polynomial centered at x equals -1. So we would have the function evaluated at -1 over 0 factorial times x minus 1 or x plus 1 to the 0th power plus the first derivative of f evaluated at -1 over 1 factorial times x plus 1 to the first power plus second derivative of f evaluated at negative factorial over 2 factorial x plus 1 squared, and finally the third derivative of f evaluated at -1 divided by 3 factorial x plus 1 cubed. All right, and then when we work this out, this is going to be well, the first term is 0 over 1 times 1, so overall just 0, plus 3 over 1 times x plus 1, plus, well, the second derivative at -1 is -12 over 2 factorial, which is 2, x plus 1 squared, and finally the third derivative was 27 over 6 x plus 1 cubed. So this gives us 0, 3 times x plus 1, minus 6 times x plus 1 squared, plus 9 over 2 x plus 1 cubed. Now, of course, one could totally expand all of these things, distribute the coefficients, and recombine for a more standard form of a cubic, but this is a perfectly good polynomial. So I consider this to be done. Now, our goal is to take a look at the patterns of the derivatives and try to find some sort of closed form for the nth derivative of this function evaluated at -1. So what does f to the nth derivative of f evaluated at -1 look like? Well, let's see. When n is 0, that's just 0. And then we got 3, and then 12, 27, 48, 75. And so one thing we notice is that they're all multiples of 3. But which multiples of 3? It's 0 times 3, 3 times 1, 3 times -4, 3 times 9, 3 times -16, 3 times 25. So some observations: 0, 1, 4, 9, 16, 25. These are the square numbers, right? And then we're alternating signs. We're going positive, negative, positive, negative, and then, well, starting with 0 and then positive, negative. So it seems like First of all, there's this 3 involved. There's a square involved. And there's a -1 to the n involved. But it's negative when n is even. So that means we have an extra negative on there. So the power here is odd when n is even, and it's even when n is odd. So that gives us our closed form. So finally, the actual Taylor series for f of x centered at x equals -1 is a sum from n equals 0 to infinity. It's the nth derivative evaluated at -1 over n factorial times x plus 1 to the n, but we found a closed form for this very expression. It's that, right? So I can go ahead and rewrite in our n factorial. I can put back in our x plus 1 to the n, but I want to note that this is 3n squared minus 1 to the n plus 1. And that is our Taylor series for this function. All right. Thank you very much. I'll see you in the next video.